Everybody. So in this question, we've been given that f of x is 1 over the square root of 4x squared plus 9. And we've been asked to use a suitable substitution that we need to state clearly to show that the integral of f of x with respect to x can be written in this form, where c is a constant and we need to find the values of a and b. So the first thing we need to do is think about our substitution. If we let x equal 3 over 2 sine u, then when we find x squared, we'll square this 3 to get 9, we'll square the 2 to get 4, and this will become the sine squared of u. I've chosen this because this division of 4 will cancel out this multiplication of 4, and this 9 will allow us to factorize out the 9 here as well. So the integral of f of x with respect to x will be the integral of 1 over the square root of x squared, which is this, plus the 9. And this is all integrated with respect to dx. But if we're letting this equal x, then dx by du will be 3 over 2 cos u. So dx will equal 3 over 2 cos u du. And we can write this in place of dx. Okay, so now we can tidy this up. We'll begin by cancelling out the 4's, and I'll move this 3 over 2 to be front of our integral. And then we can factor out this 9 in our denominator, so we get this. At this point, we can separate the root 9 and the root of sine squared plus 1. And we know from the hyperbolic identity, cos squared u minus sine squared u, that we can move the negative sine squared u to the right-hand side. So we can write this as cos squared u. So now we get cos u over the square root of 9 times the square root of cos squared u. We can simplify this square root and square term, and we can pull this third out in front, and that will cancel with this 3. These two will cancel, so we're left with 1/2 of the integral of 1 du. And we can integrate this quite easily, and we get 1/2 of u plus the constant term. So now we need to substitute x back into this u. And we said up here that x is equal to 3 over 2 sine u. So if we take the r sine of both sides, then u will equal the r sine of 2x over 3. And we can substitute this into here. So we get the integral of f of x with respect to x will equal 1/2 of 2x over 3 plus the constant term. So if we go back to our question, we've worked out a and we've worked out b. A is 1/2 and b is 2 over 3. Okay? And then for part b, find an exact form in terms of natural logs, the mean value of f of x over the interval 0 to 3. So we know the mean of a function is 1 over b minus a multiplied by the integral between the limits of a and b of that function with respect to x. So we can write this as for b will equal 3, for a is 0, we have our limits using this function of x. And we've already worked out what this integral is. So now I can move this 1/2 out in front, so this becomes 1/6. When we substitute in the 3, this becomes 2. And when we substitute in the 0, this becomes 0. So we can write this as 1/6 of the r sine of 2. And we can work this out using natural logs from what's given in the formula booklet. We know in this case that the x value is 2 and the a value is 1. So we'll substitute them into here. So finally, we can work out this, and we get 1/6 of a natural log of 2 plus root 5. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, you can find lessons on this topic from my website, mrmathematics.com. I'll leave a link in the description below.